All right, let's just dive right in. Today, we're looking at a tool that could fundamentally change how you work with Autodesk Inventor. I'm talking about transforming it from just a powerful modeling tool into, well, a truly intelligent engineering partner. So I want you to just start with this one question. Seriously, think about it. What if your CAD model wasn't just a collection of geometric shapes and sizes? What if it actually understood the real-world engineering, the physics behind all those dimensions, live, in real time?
Because right now, let's be honest, every single engineer pays what you could call a hidden tax. You know what I'm talking about? It's that constant, nagging friction of juggling spreadsheets, manually converting units, and just hoping, praying, that your calculations actually match up with your geometry. It's a tax on your time, your focus, and frankly, your creativity.
And this slide just lays it all out, doesn't it? On the left, that's the old way. This struggle is real, right? Formulas are buried deep inside one specific model, you're constantly converting kilowatts to horsepower, and you live in fear that one tiny change is going to force you to manually update everything. But on the right, that's a whole new world. A connected, intelligent system where the engineering logic lives and breathes right alongside the model.
Let's be really clear about the pain points here. Inventor is a fantastic tool, don't get me wrong, but its native parameter manager, it just wasn't built for deep engineering work. It has almost no unit awareness. I mean, try working with something like density natively. You'll see what I mean. Complex formulas are clunky, and if you want to connect to that master spreadsheet with all your company's calculations, well, good luck with that. And yeah, iLogic is powerful, but man, it's a steep learning curve for what should be a simple task.
So how do we get around these limitations? What if you could get what one user called backdoor access to Inventor's core and hook it up to a much more powerful engine?
Well, that backdoor, it's the CalcsLive Plug for Inventor. It's this lightweight, really elegant solution designed to solve these exact problems.
And that quote really hits the nail on the head. It's not about replacing Inventor, it's about unlocking the potential that's already sitting right there, just buried under all that manual work. It's about making the tool you already know and use smarter.
Okay, so how does it actually work? I know it might sound complex, but the way they built it is surprisingly simple and, this is key, non-intrusive.
Now this slide shows you the whole system at a glance. The most important part to see is that component right in the middle, the one they call the bridge. Think of it like a translator. It's a small local app that sits on your computer and creates a direct, secure connection between your Inventor model and the powerful CalcsLive calculation engine. It just reads and writes parameters back and forth.
The whole thing really just boils down to two simple components. First, there's the bridge server. It runs locally on your machine, talking directly to Inventor. No complicated setup, nothing crazy. Then you've got the web dashboard. This is where you do all the fun stuff, right in your browser. You define your engineering logic, you manage your calculations, and you map everything to your model.
And here is the truly clever part. This is genius. You might be wondering, how does it store all these connections without adding weird files or custom properties to your model? It uses the native comment field. I mean, think about that. The mapping information is saved right inside your normal Inventor part or assembly file, but it doesn't interfere with Inventor's normal operation at all. Your model will still work perfectly for anyone who doesn't even have the plug.
And the way you do this mapping is incredibly simple. In the comment field for any parameter in Inventor, you just type in this little text tag. That's it. There's no complex code, no scripting. You're basically just leaving a little note for the bridge that says, hey, you see this length parameter? I want you to connect it to my variable L over in my CalcsLive worksheet. It's that easy. So, all of this adds up to a workflow that is genuinely transformative. Now that we know how it works, let's focus on why it matters. What does this new connected process actually feel like for you, the engineer?
Well, it looks like this. This is the web dashboard. On the left, you've got your Inventor parameters pulled in live from your open model. On the right, your engineering calculations. And connecting them is literally as simple as dragging and dropping. You change a value in your calculation, and boom, it updates in Inventor. You tweak a parameter in Inventor, and it updates the calculation. It's a true two-way conversation.
Let's just break down the advantages side by side, okay? Where Inventor has very limited unit awareness, CalcsLive handles over 67 engineering categories. Where Inventor formulas are basically trapped inside a single model, CalcsLive calculations are separate, reusable, and you can use them across all your projects. But for me, the most important line on this whole table is that last one, zero vendor lock-in.
Because of that clever comment-based mapping, you can stop using the plug tomorrow and your models are 100% fine.
So if you remember nothing else from this, remember these 3 numbers. Over 67 unit categories right at your fingertips. Just 2 simple components to get it all running and absolutely 0 vendor lock-in.
You know, all of this leads to something much bigger than just another productivity tool. It really represents a fundamental shift in the design process itself. It's the reason why users who adopt this kind of workflow say they can never, ever go back to the old way.
I love this piece of feedback. That word bureaucratic, it's perfect, isn't it? It just captures that feeling of doing pointless, administrative busy work that gets in the way of doing real engineering. This tool just strips all that bureaucracy away, letting you actually focus on the design.
And that's the ultimate takeaway here. We are moving beyond just simple geometric modeling, where the engineering is kind of tacked on at the end, to a world of true engineering-driven modeling, where the physics and the math are an integral, live part of the model from the very beginning.
So I'll just leave you with this final thought. Take a look at your own workflow, at all those spreadsheets, the manual conversions, the double-checking, and just ask yourself, isn't it time to stop letting geometry dictate your engineering and instead to finally let your engineering drive your design?